Hello, welcome back. This is the second half of the 18E notes on the normal distribution. Okay, I actually tracked down a TI-83 so I can show you what it's supposed to look like on the TI-83. Okay, so let's see again. We have our directions. Oops, sorry. Let's see. I gotta get this calculator back. There it is. Okay, so we do second variables and then normal CDF. And you go in to that there. Okay, and then you enter in, again, you enter in your, first thing you want to do is you enter your low range and then your upper range. So we're going to do 100. Everything's separated with a comma. You don't have to do any spaces. To 130, comma. And then 110 is our mean. So then the mean comes next and then the standard deviation comes last. So 110 is our mean, comma 8. Close the parentheses, push enter, and we get our 80. There's where we get our 88.8%. Okay? All right, let's look at B and the B and C portions of this. All right, so it's known that 8% of the pairs weigh more than m grams. That's not milligrams, but that's m grams. Okay, so find the value of m. All right, so this piece here, here's our 8%. Known that 8% of the pairs weigh more than mg. Find the value of m. So we want to look. We're really looking for this piece right in here. So we're looking for 92% of that data. Okay. So we're going to do something similar, and we're going to use our graphing calculator to do find this inverse norm. All right, and that is here second variables, and then you scroll down to the third, which is the INV norm. All right, so bear with me so I can pull up the calculator. And here's what we're going to do. So instead of putting a range in, you actually just put in we're looking for this 92%, so we put in 0.92. All right. So second variables, and then we go down to the INV norm. Okay. And then again, we're going to put in 0.92. Comma, and then we put in our mean and then our standard deviation of 110, and then our standard deviation of 8. Close our parentheses, and we get 121.24. Oops. Come on. I don't know what the heck that is. All right. So, sorry, what were we looking for? M. So that means that m has got to equal 121 grams. Okay, so we found the value of m. All right. And then let's try one last piece here, and that's calculate the expected number of pairs that weigh less than 105 grams. All right. So weight that's less than 105 grams. So here's 105, and it's everything below that. Okay, so it's pretty similar to this first piece here, because you're first we're going to find the percentage, and then we're going to actually calculate the actual number of pairs that weigh less than 105 grams. So first we want to find what percent this is. So it's just like the first one, and again they give us this. Let me go back here. They give you -9 times 10 to the 99999. Again, that's just really super close to 0, so why not just cut to the chase and put 0 in there? Okay, so down here it also says that -9, so I'll just put zeros in for both of those. And now we pull up our graphing calculator. And again, I think more people have the 83, so I'm just going to use that. All right. So, oops, I keep forgetting to pull that up. All right. Let's clear that out so it doesn't look too confusing. So we're going to go back into second variables, and we're going to go to the normal CDF again. Okay, and push enter. And then, so now we want to know everything that weighs less than 105 grams. So we want to start at 0 and then go up to 105. And then again, we put in our mean, which is 110. And then our standard deviation, which is 8. So 0, 105, 110, 8, and we push enter, and we get 26.6%. Okay, so this blue section here is 26.6% of the data. So we want to find out what 26.6% is of 250. So let's just do this times. So it'll take our answer and multiply it by 250. And we get 66.49. So it's 66 or 67 pairs that will weigh less than 105 grams. Okay? So that is how you do this stuff on the graphing calculators. All right, and that is the normal distribution. Okay, so you should now be able to say that I can use the normal distribution to solve real-world type problems. Okay, if you have any questions, please ask. Thanks.